We have discussed last week the different ways of expressing the concentration. So those are uh, percent by mass, percent by volume, molarity, and molality. So now we are going to discuss the stoichiometry in solution reactions. So our lesson objective, number one, perform acid-base titrations to determine concentration of solutions. And number two, perform stoichiometric calculations for reactions in solution. But before that, let us have this one. So we have the four main types of chemical reaction. So this one is for your review that what you have tackled about balancing equation when you are in your early studying of chemistry. So now we have the four main types of chemical reaction. So those are the synthesis, decomposition, single replacement, and double replacement. So the capital letters represents elements, all right? So for example, if we have two elements here that is being combined together, and it may result to a chemical reaction. And its product, pwedeng nagkasama lang sila na katulad ng nasa ating screen. So this one is called the synthesis. So let us have an example. Let us write two atoms of hydrogen and an atom of oxygen. So if we say synthesis, the result may be like this. So magsasama lang po yung naging resulta ng ating chemical reaction. For the second one, the decomposition, from the word decomposition, we break down, no, from being a compound, AB, and it will have or undergo chemical reactions, and it may result to the decomposition or breaking down two elements. Okay, so for example, we are going to use H2O, and then it will undergo chemical reaction. So this one would be H2 plus O. Alright? Then the third one is the single replacement. So as you can see, dito sa ating left side, the partners are A and B, and with a single element in this part. And it goes chemical reaction. So ang naging resulta niya is AC plus AB. And the fourth one is the double replacement, wherein yung elements natin, nagka-switch sila or nagkapalit po sila ng partner nila in the product. So we have A, and the letter B becomes on the other side. Letter C is here, and letter D sa kabila naman. So that is the double replacement. So those are po the four main types of chemical reactions. Now, let us proceed with acid and base. So we are going to differentiate the two. So we have the acid here and the base. So if we say acid, it tastes sour, while base is bitter. And for acid, when we dip the blue litmus paper to acid, it will change into red. And for base, the red litmus paper will turn into blue. Both of them will react and form salts. So if they are added to base, or the acid is added to base, and the base is added to the acid, they will both form salts. And both of them promote chemical reaction. Okay, so our lesson for today, yung ating titration wherein acid and base are important in our uh, solution. So titration is the technique where a solution of known concentration is used to determine the concentration of a known solution. So we have here the relationship or the general formula for the titration. We have M sub A, V sub A equals M sub B, V sub B, wherein letter M stands for molarity, letter V stands for the volume, and letter A for acid, and letter B for our base. Alright? So this is our general formula for titration. And based from this general formula, we will break down this into 4 more different formulas that we can use for titration. So let me just clean our slide. Okay. So we are going to break down the formula into 4, wherein we need the formula for the molarity of acid, volume of acid, the molarity of base, and the volume of base. Now, let us first proceed with molarity of acid. So as you can see, what is the term nakasama ni molarity of acid dito sa ating side na to? So that is VA. So we need to divide both side by VA. So let us cancel out the same unit. So our formula in finding MA is MB VB over VA. Next, we have VA. So, sino yung kasama ni VA dito sa area na to? So, that is MA. We need to divide both sides by MA. Alright? Then, we need to cancel out these two para maiwan na po si volume of acid. So, our formula for VA is MB VV over MA. Next, we have the molarity of base. So for MB, we are going to divide both sides by VB, okay, in order to cancel out this same. Alright, so ang natira po is MB equals MA VA over VB. And for our last, that is VB. Let me just clean this first. Alright. So we have VB. So in order to get the formula in finding VB, we need to divide the both side by MB. So we have VB. Alright, so let us cancel the 2. Now, yung naiwan natin is MA, VA over MB. So these are the 4 formulas that we have for titration. Now, let us apply this to word problems. Alright, so as you can see in our slide, we have here the first problem for titration. So let us try computing this one. So let us read a problem. Calculate the concentration of hydrochloric acid solution determined by 50 ml of the acid is added to a flask. So we have here 50 ml of the acid. So this one is the volume of acid. Next, indicator is added and 29.6 ml. So since we already have the volume for acid, so this one is the volume of our base. Next, 29.6 ml of 0.967 moles. Okay, so this one is our molarity of the base. All right. So, what is the required po to reach the end point? So, our missing here is the molarity of the acid. All right. So, we need the formula for MA. That is MA equals MB times VV over VA. All right. Now, let us substitute the given to the formula. So we have 0.967 moles and the volume or VB is 29.6 ml. Divide by VA which is 50 ml. Alright, so you need to cancel out the same unit. So MA is 0.57 moles. So this is the required molarity of the base or of the acid rather to reach the end point. Alright, so let us clean this and turn to problem number 2. So in problem number 2, we have 17.45 ml. Okay, so this is the first given of 0.180 moles nitric acid. So it means that this is the given for acid and we have ml here, so it means that this is the volume and M stands for moles, which is the unit for molarity. Okay, now we have 14.76 ml, which is used, or ml is used for the volume, and that is for the base because we already have here the volume of acid. Now, the required or the concentration of aluminum hydroxide or the molarity of our base is missing, so we need to get its MB. The formula needed to find MB is MAVA over VB. Now, let us substitute the given to the formula. So we have 0.180 moles rather multiplied by the volume of the acid ml over the volume of the base, which is 14.76 ml. So cancel out the same unit. So our molarity of base is 0.21 moles. So this is the required moles of our base to uh, to reach the end point. All right. And for the third problem, we have here 80 ml. 80 ml of potassium uh, hydroxide. So potassium hydroxide is KOH. Then it was titrated at the end point or to the end point with 39 ml of 6.5 moles 6.5 moles of hydrochloric acid. So from the word hydrochloric acid, so 39 ml and 6.5 is the acids. Now, we have here the unit ml, so that is our volume, and moles for molarity. And ml also is the unit for volume. So it means that 80 ml is the volume of our base because we already have the volume of our acid. Okay. Now, so the missing in our problem is our molarity of base. So we have the formula MaVa over Vb. So let us substitute the given to the formula. So we have 6.5 moles multiplied by 39 ml over the Vb, which is 80 ml. Cancel out the same units. So proceed with the computation. So our molarity of base is 3.17 moles, which is required for the solution to reach the end point. Okay. So now we have several factors affecting the solubility. So number one is the temperature. So this affects the solubility of both solids and gas. So mapapansin natin, if we are using, so morning, so if you are using hot water to drink coffee, so syempre, pag nilagay mo na yung pack of coffee dito sa hot water, mabilis matunaw yung ating solute, no? Rather than using cold water, no? Kapag nagtitimpla yung mga mami nyo ng Milo, ganyan. So they always start using hot water muna. 'Di ba? Hot water, then pag gusto mo ng malamig na Milo, you will just transfer this into cold water. Kasi pag diretsang sa cold water kayo nagtimpla, magbubuo yung ating solute. Number two is the pressure. So pressure only affects the solubility of gases. So we have here a picture or a photo of the pressure, the under normal conditions. So we have here the water and the gas molecules under normal conditions. And the second picture is when the pressure is increased. So as you can see, more gas molecules are soluble at higher pressure because we can compress the molecules of gas. So that's why mas mataas na pressure, mas nagiging soluble ang gas molecules. Alright? So now let us try having this simulation. So this one is related to your balancing equation. So let us know balancing equation. Okay. So we will have, so let us measure how well do you know a balancing equation. So let us try level 1. Okay. So here, as you can see, we have the equation P4 plus F2 undergoes a chemical reaction that is PF3. So in balancing equation, you need to balance the number of elements in the left side and the number of elements on the right side. So kailangan parehas po ng bilang yung elements na meron tayo. So for beginners, you need to list down, if medyo nalilito pa, list down all the elements in the left and right equation. So in the left equation, we have P, which is 4, and F, which is 2. Next, in the right side, P is 1, and F is 3. Alright? So, we need to adjust the numbers na nandyan sa unahan para mag-balance yung ating equation. Alright? So, we are using the petcolorado.edu. Alright. So, you need to adjust also the 0 into 1. Kasi pag hindi natin in-adjust ito into 1, this is just for the application ha, you will get an error answer. Pero in reality, you will not write number 1 sa harapan kasi kapag wala siyang 1 or wala siyang number sa harap, automatic that is 1. Alright? So let us try putting here 4. Alright. So here, let us have 4, 5, 6. All right. So let us try 6. So let us check if the equation is balanced. So let us try counting this. So now we have P is still 4, and F we have 6 times 2, that is 12. Okay. On the right side, we have P now is 4, and F is, we have 4 here and 3 here, so we need to multiply 4 times 3, so that is 12. So I think we are now balanced. So let us try, or let us check our work. Okay, so our answer is correct. So let us proceed with another example. Okay, so in this example, we have NO and 2 plus O2. First, for beginners, list down the elements para po hindi kayo malito. And NO on the other side. So here we have nitrogen 1, oxygen 1 also, and nitrogen here is 2, and oxygen is 2. Okay, so now let us adjust to get them balanced. So let us adjust this into 1, and let us have here 2. Okay, so by just computing if they are already balanced, let's see. So 2 times 1 here is 2, nitrogen is now 2, then 2 times 1 again is 2, so oxygen is also 2. So I think we are now balanced. So let us check. All right, so very good. We are done in our lesson.